Hey everyone. Okay, well, you finished Tool 3 in the book, right? So let's go over plotting the positions of objects in the sky. Specifically in in altitude and azimuth. So, um, your first question's here on page 9, right? We're looking at the azimuth measurements around the horizon. And if due north is 0 and due east is 90 degrees azimuth, then northeast must be 45 degrees, right? Because why? Because azimuth starts at north and it increases as you look to your right or clockwise around you, right? So azimuth increases this way. So 0 at north, 45 degrees azimuth at northeast, 90 degrees at east. Keep going southeast. Southeast must be 135 degrees azimuth then. 180 due south. Now we're in the southwest, and that's going to be 215 degrees. 225. I knew I was wrong there somewhere. There we go. Again, we work in pencil because we are fallible creatures. 225, 270 due west, 315, that's why the 15 was in my head, 315 degrees azimuth in the northwest, and then we've gone 360 degrees around, so we're back at 360 degrees azimuth or 0, same thing, back due north. Right? So that one number, azimuth, tells you where around the horizon you should be looking, because we've broken the circle of the horizon into 360 degrees, like you would any circle. All right? Okay. No questions on the next page. So let's look at these practice problems. Draw a curved arrow to show where azimuth is measured. Well, we kind of just did, right? So if we say, all right, so azimuth starts at 0, starts due north, right, at 0 degrees azimuth. And it increases going around you clockwise. So azimuth increases like that. Question 2. Draw a curved arrow to show where altitude is measured. Well, altitude is measured from the horizon going up, right? If something is on the horizon, it's at 0 degrees azimuth, and then it increases going up, until you're looking at the point straight up over your head at the zenith, right? Which is 90 degrees above the horizon. So altitude increases like that. Okay, now let's try to get a good estimate for the altitudes and azimuths of star A and star B at those 4 positions. Let's see, where should we start? I'm going, well, let's start with the easiest. I mean, you'd probably start with A1, but I'm going to put a pin in that for just a second. Let's start with something even easier. Let's start with A3, right? Because A3 is right above the, right? It's right above the northern horizon. So what is due north? That's 0 degrees azimuth. So there we go. And how many degrees above the horizon is A3? Well, if you draw a line from the star to the Earth, or to you rather, standing on the Earth, to the horizon, what does that angle look like it is? I'm going to estimate 15 degrees. If you got anything close to that, 15, 20, 25, you're in the right ballpark. So something in that, your answers might be a little different than mine, but they should be fairly close. I'm going to say 15. Should be near there. All right. Now A4, let's look at these two here. A2 and A4 can be a little tricky. why is it tricky? Well, this is a two-dimensional diagram. But, of course, if you're standing on the Earth, you can look in all three directions, right? If you're standing right there, you can look left or right, you can look up or down, and you can look into the page and out of the page. So if you're looking into the page, right, you're looking into the background of the image toward B4 there. What direction is that? If you're looking into the background, well, that's due east, right? Which is what? That's 90 degrees azimuth. And if you're looking out of the page into the foreground of the image, then you're looking due west at 270 degrees azimuth, right? And then just to finish our scheme here like we had on the previous page, right? Over here must be due south at 180 degrees azimuth. What about A2 and A4? Well, let me clean this up. I'm going to do a little erasing to clean this up for a minute. A2 is in the foreground, right? Where is A2 on the horizon? Well, it would be above here. If we drop a line, down to the horizon, A2 is above that point on the horizon. Whereas A4 is more in the background, right? A4 is going to be here on the horizon. So that'll give us a good idea of the altitudes and the azimuths. A2, what would you say? Well, if it's on the horizon, that's 0 degrees. If it's at the zenith, that's 90 degrees azimuth. Sorry, 90 degrees altitude. So A2 and A4 are both kind of halfway between the horizon and the zenith. So I'm going to say those are both 45 degrees. Maybe a little more, maybe a little less. Maybe it's 40 degrees, but something in that ballpark. All right. What about the azimuths? Well, A2 is above here on the horizon, which is what? Well, it's not west, it's not north, so A2 must be above the northwestern horizon. And the northwestern horizon has an azimuth of, what did we just say on the previous page? 315 degrees azimuth. Whereas A4 is above this point on the horizon, right? It's not north, it's not east, it must be northeast. What's the azimuth for northeast? That's 45 degrees. Oh, I'm not showing you what I'm writing. Right? So A2 is, both two positions 2 and 4 are at 45 degrees altitude, but A2 is in the northwest, 315 degrees azimuth. A4 is 45 degrees azimuth in the northeast. Right? Okay. Now let's look at A1, because why did I say let's do the easier ones first? Well, the tricky thing about A1 is, where is A1? It's straight up over your head, right? What's the altitude of the zenith straight up over your head? Well, that's 90 degrees altitude. What's the azimuth, though? Well, if you're looking straight up over your head, it doesn't matter whether your body is facing north, east, southwest, right? Your body might be facing northeast, southwest, but your face or your eyes are looking straight up. So the zenith, the point straight up over your head, it's at all of the azimuths at the same time, right? The zenith is the point where all of the lines of azimuth meet up. All of the lines of azimuth meet up at the top of the sky at the zenith. So whatever number you put there, it's the right answer. Because you could be facing any direction as long as you're looking up, and you'll see star A at position 1. So whatever. As long as you put a number between 0 and 360, you're right. Okay. What about B? What about star B? Oh, Polaris. I almost forgot Polaris. Okay, so what's Polaris? Well, Polaris also looks like it's maybe a little more than halfway up the sky, right? From zero to Polaris there to the zenith. Polaris looks like it's a little higher than 2 and 4. I'm going to say, how about 50 degrees? That's probably about right. Again, if you put 45, 40, in that ballpark, sure. What's the azimuth, though? Well, for sure, Polaris is the North Star, so Polaris must be right above due north on the horizon, so gotta be 0 degrees azimuth. All right, now star B. All right, star B, position 1. Star B at position 1 is right above due south on the horizon, so that's going to be 180 degrees azimuth. How high up is it? How many degrees above the horizon, right? What is the angle between the horizon, you, and that star? And I'm going to say 40? Let's say 40. Yeah, okay. I think that seems reasonable. Maybe 30. I was thinking 30, but probably 40. So altitude 40 degrees, and it's in the southern sky, so it's 180 degrees azimuth. All right. Something like that. 30, 40, 45, something like that would be good for the altitude for the B at 1. All right. How about, I'll just leave my, try to get it all in the frame here. Okay, so at position 2, though, where is star B at position 2? Well, it's right on the western horizon. So if it's right on the horizon, that's got to be 0 degrees altitude, and it's due west, so 270 degrees azimuth. Position 3 is below the horizon, right? You can't see it. So no point in trying to map where it is in the sky, because it's not in the sky. It's invisible to you because it's down, being blocked by the Earth. Then B4 is up there, right? So it's just about to rise in the east, right? Just rising on the eastern horizon. So if it's right on the horizon, that's got to be 0 degrees azimuth. 0 degrees altitude, right? It's right on the horizon. And it's right above where on the horizon? It's right above due east. So that's 90 degrees azimuth. Okay. So those two numbers, azimuth and altitude, those two numbers tell you exactly where you should be looking on your sky above your horizon, right? Azimuth tells you what direction to look. Altitude tells you how high up to look. And given those two numbers, you know where you should be looking in the night sky from your point of view. Okay? And as you can already see from this diagram, where the star is will tell you how it's going to move, right? Every day as the Earth rotates, star A goes in this circle. And so all right, if star A starts out at the zenith, it's going to go down here, and then down here, and then back up there, and then back to where it started 24 hours later, right? So the position, that's why this topic is called the position and motion of stars, because where a star is right now will determine how it moves next. Not because the stars are actually moving, but because the Earth is rotating over the course of one day, right? Okay, so hopefully that's not too tough. Hopefully that's making sense. And if that's making sense, then go on and do the Tool 3 practice, and then move on to Tool 4, and we'll pick this up with Tool 4. All right, see you then.